Hey folks, welcome to another session in a series of sessions where we're talking about how to grow from a junior developer to a senior developer. And today we're going to talk about 11 real world code disasters. And before that, let me just quickly see where everyone is joining from. I see we have someone from Pune, someone from Bangalore. Of course, someone has to be from Bangalore, Mumbai, Hyderabad, all right, I see we have a bunch of representation here. In terms of experience, also I see people with 3 years experience, 1 year experience, and a bunch of diverse people. So, all right, cool. So, this is the agenda, and this is what I want you to treat each example through this lens. This is the takeaway that I want you to have after 30 minutes, which is as developers, we have a lot, a lot of responsibility on our shoulders. So don't take things lightly. A lot might be at stake. So from the next slide onwards, there are 11 examples. We're going to go through each one of them. And if you have any questions anytime, feel free to put them in the chat that time itself. And yeah, here we go. I hope you have as much fun going through these examples as I had curating them. So here is the first disaster, which is Apple's FaceTime eavesdropping bug. This happened in 2019, and this was sort of like a uh, edge case handling bug. The edge case, which was not handled correctly, was that a call recipient was added before accepting. So, what it looked like was if you are calling anyone with FaceTime, even before the person on the other hand has accepted or rejected, the audio from their phone, you could start hearing that immediately. And this is literally eavesdropping. You want to hear anyone, you just sort of FaceTime them and then you just see what's happening, what are they talking about. This is uh, I put this as a first example because in the last session we talked about boundary conditions, how testing at boundary conditions is super important. um, a normal case which lies in the middle, a um, normal case which lies between the boundary conditions, they typically run on the happy path. But the cases which are right at the edge, what just happens before and after at the edges, and this is why it literally is called edge case, those are very very important, and we sort of underestimate how big of a problem this can create. And you can see this actually happened with one of the biggest companies out there, Apple. So make sure, I think the lesson here is, make sure you test your boundary conditions whenever you're writing code. If you have any questions anytime, just put it in the chat and I'll answer them. And yeah, meanwhile, we'll move to the next example. This was uh, this is called like rocket explosion, and this actually explains what pretty much happened, which is a software bug caused the rocket to self-destruct after launch. And what went wrong? In two words, it was an integer overflow. So a larger number, which was supposed to be a 64-bit floating point number, it was stored in a smaller variable which could not hold such large numbers, and it led to an overflow. And like no test case covered the scenario in a real launch environment. And also one of the things was they reused a lot of code from the previous version, version 4, without proper validation. The impact, and again, like all through this session, I want you to focus on how small things lead to actual business impact. The impact was $370 million were lost in less than 40 seconds. And if you go at the core, what was the issue? Integer overflow. That was it. So again, whenever you're working with large numbers, make sure to test for this, how the control is flowing, how the data is flowing, and make sure to have appropriate test cases. Do a lot of stress testing. In either the last session or the last to last session, we also talked about uh, how to use AI to generate a lot of tests for you. So make sure you do that. Like don't just write one or two test cases and be done with it. Try to do a stress testing. Like even for simple things, try to write as many test cases as possible, because that is something you only write once, but you use them forever. uh, I hope that makes sense. If you're still with me, just drop a yes in the chat. Just want to see if everything is clear, audio is clear, you're able to understand the examples. Okay, okay, I start seeing yeses in the chat. All right, let's move to the next example. This was again a big bug, which is known as, this actually is known as the 440 million bug. And if you Google it, again, all of these things are real. You Google anything, you'll find 10 blog posts talking about this bug. So this is Knight Capital's $440 million bug. And the issue was there was a deployment error, which led to a trading algorithm behaving unpredictably. The core issue was that there was some old unused code which was not supposed to be run, and it was accidentally reactivated. And usually dead code is sort of removed from the code base, but they had put it there just thinking, okay, maybe we'll reuse it some other time, and accidentally that got reactivated. And again, lack of tests. So if you see all of the major issues, the one of the problem is always lack of tests. Okay, I think I'm back. Are you able to hear me correctly? Give me a yes in the chat. Yes, perfect. Cool, cool, cool. So I was talking about, this was a deployment error which led to uh, trading algorithm behaving unpredictably. And the issue was that there was some unused code which was there, which was put, usually that a dead code is removed from the code base, but they thought, okay, we'll do that some other time, maybe we'll reuse it. And that got accidentally reactivated. And of course, lack of tests. If you'll see, most of the errors, they happen because testing was inadequate. If you have a lot of tests, most of the times you'll catch the issues. So there was a lack of tests to catch the issue before deployment. And of course, the code quality, there was not a lot of modularization, which made it hard to detect the problem. Like if you guys go deep into it and see if there was some code which was not being used and that got started being used, so like the code was not organized correctly. So what was the impact? The impact was they lost $440 million in 45 minutes, and it forced the company into acquisition. Like just understand how big this is. Like they just like woke up, this is okay, okay, this would be like a normal day, and in 45 minutes the company was forced to get acquired because they could not afford that much of a loss. So like the whole company sort of vanished. That's like a pretty big thing in terms of impact. Ravi's asking how to create a boundary between significant number of test cases and not adding unnecessary test cases. So maybe I would have answered very differently a couple of years back. But as of today, in 2025, since we have a lot of AI capabilities, what I would recommend is just create a lot of test cases, because the time cost of adding more test cases has become very less. You just describe the test case and AI will help you write those tests. So try to add as many tests as possible, I would say, because again, the time cost is very less. The resource cost is anyway, like it has been low for a long time now. Tests run pretty quickly now, like for a long time now. But before, you had to spend a lot of time writing them. Nowadays you can just describe a lot of tests and you can get them generated. So leverage the power of AI in the right way. And one of the best ways, like top two, top three ways of using AI is writing test cases. Let's move to the next one. This is GitLab, and the data loss happened because there was again inadequate testing and missing backups. What happened? One developer accidentally deleted the production database. It led to 6 hours of downtime and partial data loss. The problem there was, of course, they thought that, okay, backups are in place, but the backup system was also broken. And no one realized that because there were no tests ensuring that backups worked. So, takeaway for us is when we are taking backups of our database, of any snapshots of anything that a code is dependent on, make sure that those backups are also working. Like if you just uh, put that backup mechanism 5 years back, it might not work today. So make sure that those are being tested regularly as well. So you can back up and restore. So like this is the complete loop or the flow, which is you back up something and then you delete everything and then you try to restore to the original state from that backup itself, and then you see how much is the difference. Is it able to restore 100%, or are there any new interface changes that needs to be modified, the code needs to be modified for anything. So yeah, make sure your backups work. Just having a backup uh, is not really sufficient. Let's move to the next one. Again, it might seem very simple, but Microsoft Teams, like Microsoft is one of the, again, biggest companies out there. The Teams went down due to an expired certificate in 2022. What was it? An SSL certificate expired. And if you have worked with front end, you know what an SSL certificate is. It's what makes your website work on HTTPS instead of just HTTP. So what went wrong? There was no automated monitoring for certificate renewals, and like no test coverage for these scenarios. Again, these might be happening once a year. Like renewals typically, you get an yearly subscription, yearly certificate, or even a higher terms certificate. But then again, there was no proper test coverage for that. And the impact, millions of remote workers were affected for hours. Let's see the next one. This sort of um, like I felt very bad learning about this, which was Boeing 737. It crashed because of error handling. The sensor data, there was some faulty sensor data that triggered automatic nosedives, and the software relied on a single sensor. There was no redundancy or proper error handling. So if you're relying on only one thing, which is also known in the software industry as a single point of failure, if you're only relying on one thing, then you need to ensure that that one thing works really, really accurately. And what is the impact of it not working accurately? In this case, the impact is that, like, your plane is crashing. So that's pretty bad, right? um, and of course pilots were not informed about this behavior, and there's no way to disable it easily. So yeah, I think again, something very sad to hear about. Let's see the next one. Tesla's software update bricked cars. um, if you have been following Elon Musk, or if you've been following electric vehicles, you might have heard of Tesla. The hardware, of course, is sort of similar. It runs on electric cells. That's the difference between a Tesla and a normal car. Like it runs on electricity, but it also has a software which almost is like your OS in your mobile, which gets updates over the air. Just like your phone gets an update, next version ka update, it gets over the air. The car also gets an update over the air. And that update in 2022 was not sufficiently tested on real hardware. And when it went live, thousands of Teslas were unable to start. Like, just think about how ridiculous this is. You have a car, you have paid full amount for the car, like lakhs and lakhs of rupees, you have paid for a car, and because of a software you're not able to start the car. Like that's like ridiculous. Like if you go and tell your parents or your grandparents ki hey because of a software bug I'm not able to start my car, they'll say अरे भाई क्या पागल हो गया, what is this? But this actually happened. And uh, there's no quick rollback mechanism. So lesson we can learn from here is, whenever you're pushing an update, try to have a rollback strategy. Most big companies have this, wherein whenever they're deploying, they have a rollback strategy in place. Rollback is deployment is usually done, over a certain period of time. The deployment rollout will be done, let's say, to 5% of users first, then 15, 30, whatever, like, it will be rolled out in batches. And at any sign of a issue, a problem, then the rollback will happen. So the you need to have the rollback strategy in place. You cannot start thinking about rollback after the issue has already happened. So before starting the deployment itself, make sure you have the list of steps on what needs to be done if there is an issue, because you can never be 100% sure about anything, because it's code, right? It's uh, your code will not understand your intent. Code is a binary thing, 0 or 1. Whatever the code will run, it's absolute. You cannot like negotiate with your code. So always have in your mind that something can go wrong. So what can you do if this thing goes wrong? If you just think from this perspective, I think again that's like a good takeaway to have. All right, let's move to the next one. And this was Zoom's security flaw, which exposed Mac users. So there was a vulnerability in the Zoom's macOS client, which allowed attackers to hijack webcams. So there was some poor software design. What happened was Zoom installed. The irony is that we actually are having this meeting on Zoom. So, all right, we're talking about Zoom only. All right. So, Zoom installed a hidden web server that bypassed security settings, and there was not adequate testing. The impact was, like, Apple itself had to step in, and it had to issue a silent security patch to remove Zoom's web server. Like, think about how big this is, right? That the platform layer itself had to step in कि अरे भाई ये तो बहुत गड़बड़ हो गया है, let me do a silent security patch to remove this. Otherwise, like, anyone could hijack your webcam and just see, like, remember the first number one bug, eavesdropping. So here, this is hijacking webcams, which is you can also see what is happening, which is like a much bigger issue. If you just see like how big of an issue this is, a laptop is usually there, put either in office or in a at a desk at home, right? And you can just like log in or just have access of anyone's webcam, or basically what's going on inside the home. Pretty damn uh, like a big of issue, right? Cool. Let's move to the final three disasters that we're going to talk about today. Are you still with me? Give me a yes in the chat. All right, all right, all right. Oh, okay, someone said why. Wow, wow, I think we are sort of, that also works. Cool, let's see the next one, which is at GitHub in 2018, a routine database migration led to a widespread data loss. And what went wrong was a destructive command was run in production without enough safety checks. And I think this is something, uh, at some point in your life you will do this, which is you will mess up with database in production. I have done it. Most of my friends have done it. You either would have done it already or you would do it sometime in your career. That's totally fine. Just make sure that you have, again, you have rollback mechanisms in place. That was the issue there, which was, uh, there was a lack of proper rollback mechanisms and insufficient test coverage for migrations. So the impact here was that data recovery took more than a day, and like GitHub's issue, right? So it affected millions of developers, like a big thing. let's go to the next one, which is Toyota's unintended acceleration bug. It's been some time, more than a decade now, but the issue was that a software bug caused cars to accelerate uncontrollably. Again, I feel uh, like just hearing about this, it just makes me feel that we should not uh, allow code in our life, uh, you know, very deeply or very tightly integrated, because if an issue happens, like, you're playing with a life here, and again, this is just my change in mindset, or just what I'm thinking. I'm just sharing with you raw thoughts, which is just going through these examples. I myself was sort of like, "Arey kya hai bhai, matlab, this is too much." So what went wrong? There was complex, tightly coupled code, no modular design. Again, we all are guilty of this, right? Like, I think when we start out, we do like this. That's fine. But not that that's not fine for sure. But yeah, that's how everyone starts. Lack of safety critical software testing, no clear separation between safety features and core logic. Like, there should be some limits, some uh, edge cases, or some threshold limits overall set in place, right? So that is the safety feature. Like, irrespective of what your core logic tells you to do, in this case, accelerate infinitely, but there should be like a safety feature which sort of caps it at a certain level. So yeah, in this case, there was no clear separation. Takeaway is like, have those checks in place outside of your business logic code, because your business logic code will keep updating in your feature requests, your bug fixes, or your new whatever you will do. The core logic will keep getting updated, but safety feature is something you can keep it as separate, as a layer above this, and which is sort of set in stone. Impact was, there was multiple fatalities, $1.2 billion settlements. um, all right, can you hear me? Give me a yes. Can you hear me? All right, perfect. Cool. So yeah, I was talking about whatever is the core logic, make sure you have like it's not coupled with your threshold limit layer, so that whatever you have set in the safety feature layer, that is set in stone, and that sort of overrides or limits everything else. The impact here was, there was multiple fatalities, $1.2 billion in settlements. I think money, like keeping money aside, like I feel fatalities itself is like a very big thing, right? Because of code, like it does not sit right with me just reading about this. Sorry, what is this like? Because of code, this happened, so that's not good at all. And let's see the final one, which is Threat 25 radiation overdose. This happened long back, but issue was a software bug in a radiation therapy machine led to lethal overdoses. And what went wrong was, there was a race condition which allowed unsafe states, and there were no fail safes or redundancy checks, no proper system testing. And impact was, several patients received fatal radiation doses. So yeah, that's like pretty big. Uh, Takeaway here is, when you are working with concurrency, so this is a particular example of that. When you're working with concurrency, make sure that you handle race conditions very clearly, because concurrency introduces a lot of unsafe states, inconsistent states. So make sure you think it through whenever you're dealing with concurrency. If not needed, like don't use it. If you're dealing with concurrency, make sure that it's properly tested. Okay, so we have gone through like 11 examples now. What I want you to do is take a step back. Let's close your eyes for 1 minute, and do a quick reflection. What's a one major takeaway from this session? And not just in terms of code, but in terms of think about the impact as well. So I want to do again. I have a very bad internet connection today. Okay, so let's do a quick reflection. Close your eyes and think about whatever you have discussed today. What's your one major takeaway from this session? I want you to think about that for 60 seconds. And we're going to uh, just type it out. Don't press enter yet. We're going to do a waterfall so that everyone sees it at once. And you can write one line, one word, one paragraph, whatever you feel about it. And if you want to write more, that's fine as well. But yeah, I think like this particular session deserves a reflection because yeah, I feel it's important to see, like, of course we talk about clean code and we have been talking about that for a while, but seeing things in the real world, I think that hits different. So I want you to see, I want you to reflect on what is your one major takeaway. And we'll take 10 more seconds and then we're going to read that out. And I want a reflection from every one of you because if you're here till the end, so I sincerely hope you take away something from this. Like otherwise, you're just sort of if you're just trending and not taking away something, then that time is better spent watching Netflix. But yeah, if you're here, I want to take away from you, even if it's two words, that's fine. But let's see those takeaways in five, four, three, two, one. Press enter now. All right, we have started getting some reflections. I'll wait for some more. Maybe I'll start reading out the ones that have come. This is done. This is done. Okay. One takeaway is testing sensitive code on staging first by redirecting some section of users on staging. Definitely. Like if you have a lot of users, if you only have one, two, three users, then that's fine. But if you have hundreds of users and thousands of users, always try to have a staging environment. Test your code by redirecting some section of users to the new code, and then based on how it is going, track errors. If everything going fine, then you sort of complete the deployment. I think yeah, I see most of the takeaways are around testing. Anything else apart from testing? Anything else? Again, testing is a very crucial part while developing any software. True, testing is there, but also like think about writing good code, right? uh, like whenever you're writing code, you have that kind of responsibility that will sort of like don't take it lightly. Like have whenever you're writing code, make sure that you write things very mindfully. All right, let's go to the bonus section. And this is again a very fun thing, which is PS5, which is PlayStation 5. There's a way to jailbreak it, and it's a very funny, it's a very interesting thing. And this is I'll leave you with this as a homework for the curious folks. Find it out, and if you find it, you can just reply in the comment section on this video, which will be on YouTube. So put in the comments, and I had fun reading about this PS5 jailbreaking bug. It's not even a bug, like it's just a very ingenious way that people found to jailbreak a PlayStation, and it's fun. So take a look at it, find it out how it works, and put it in the chat. And for to get notified of future sessions, you can subscribe here, Luma/Cactro. And that's all it, folks. Thanks for joining in on a Wednesday night, and have a great rest of the week ahead. Bye bye.